You, yes you, let me ask you this. Are you ready for the ultimate college algebra marathon where I saw 48 questions in 2 hours covering topics such as equations, functions, word problems, polynomials, quadratic functions, exponentials, and logarithms? Alright, let's get this party started. First question, let's solve for v in the following equation. Minus 2 times v minus 2 equals minus 5v plus 1. Well, here, all you need to do is expand this out. So this and this. All right, and for this you get minus 2v. And remember, minus 2 times minus 2, it's plus 4. Plus 4 equals minus 5v plus 1. And then what you do is you put all the v's on the left-hand side and all the constants on the right-hand side. And what you get is minus 2v plus 5v equals 1 minus 4. And then you get 3v equals minus 3, because c'est la vie. And then you get v equals minus 3 over 3, which is minus 1. So the answer is minus 1. All right, good. 1 down, 47 to go. Next question, a little bit more complicated. Let's solve for w in the following equation. Even though this is more complicated, the steps are the same. So here what you would like to do is expand everything out. Okay, so here you have to expand out twice, and what you get is 7w plus 7, and then plus 14w, and then minus 2 times minus 2, that's plus 4, equals 7w minus 7. And before you do the business of putting stuff on the left and right hand side, notice we can already cancel out the 7w here. And therefore what you get is just 14w, if you want, plus 11 equals minus 7. And therefore 14w equals minus 7 minus 11. It's almost like 7/11. And you get minus 18. And therefore, 14w is minus 18. So w is minus 18 over 14. And I believe you can simplify this to minus 9 over 7. All right? All right, next question, which is a two-part question, so surprise. So we have this equation, either solve it, say there's no solution, or say there's infinitely many solutions. But again, the method is the same, so you expand this out to get 3v plus 6 plus, 3v plus 6 plus 2v equals 7v minus 7 plus 9. And again, maybe let's simplify this a little bit. So 5v plus 6 equals 7v plus 2. And then you do your usual thing of shuffling things around. So put the v's here and then everything else here. So you get 5v minus 7v equals 2 minus 6. And you get minus 2v equals minus 4, which tells you that v is minus 4 over minus 2, which is 2. So here there is a solution, a unique solution, which is 2. All right, next part, more interesting or not. We have this equation, and again, either solve it, say there's no solution, or say there's infinitely many solutions. So again, same spiel as before. Let's expand out the equation. So 4u plus 4 minus 7 equals 3u minus 3 plus u. And then let's simplify this. So 4u minus 3 equals 4u minus 3. And already here we can say, well, this is always true, right? Four u minus 3 equals 4u minus 3. And if you want, you can actually put everything on the left-hand side to ultimately get 0 equals 0, which is not dioxygen, it's just 0 equals 0. And because this equation is always true, no matter which u we have, we can actually conclude that there are infinitely many solutions here. This is true for every u. So that's why we can already conclude this. And lastly, so we won't do an example of that, but how do you check if there's no solution? No solution is usually if you find something like 0 equals 1 or 0 equals 7, namely a contradiction, which would never be true. But here we do not have this case. All right, so that's enough equations. Let's move on to a little bit of functions. Okay. Next question, because you're the master of your domain, let's find the domains of this function, x plus 3 over x squared minus 9, and the domain of x over x squared plus 64. Nintendo 64 is very cool. Now, to find a domain, in this case of a fraction, you just need to make sure that the denominators are never 0. So you need to make sure this is non-zero here, and you need to make sure this is non-zero here. So first of all, let's figure out this function. Well, let's ask ourselves, when is x squared minus 9 equal to 0? So x squared minus 9 equals to 0. This would mean x squared equals 9. And this would mean x is plus or minus 3. The only numbers whose square are 9 is x plus minus 3. And basically, those are the illegal values. So you just need to make sure that x is not 3 and x is not minus 3. So if you want, in terms of pictures, what does the domain look like? It's all the numbers, x, except for plus and minus 3. So we don't want minus 3 and we don't want 3, because that would make the denominator 0. And the question is now, how would you write this as an interval? Well, the set of legal values, notice they consist of 3 chunks. Either the numbers less than minus 3, so this left chunk, or the numbers between minus 3 and 3, okay, this middle chunk, or the numbers bigger than 3. And so how do we write this in terms of intervals? Precisely what I said here. We have either this left-hand junk, which is the interval minus infinity comma minus 3. And again, parentheses, because we're excluding minus 3. And with infinity minus infinity, always use parentheses. Or, and to write or, you write union, the middle chunk, minus 3 comma 3. Or the right-hand chunk, which is 3 comma infinity. Again, parentheses, because you want to say not minus 3 or 3. So that's the domain of the left-hand function. For the right-hand one, it's much easier, because notice this quantity x squared plus 64, that's always positive. So it's always greater than 0, so it can never be 0. And in particular, this function is defined for all x. And how can you say for all x? Well, it's all the numbers from minus infinity to infinity. So the way you write this is simply as follows. Minus infinity, comma infinity. Okay, so that's very good. Again, for fractions, make sure that the denominator is non-zero. All right, next question. Next question, in my opinion, a little bit easier. Let's find the domain of h of x, which is square root of minus x plus 2. Now, remember for fractions, I told you that you need to make sure the denominator is non-zero. Here, for square roots, you just need to make sure that the inside is greater or equal to 0. Because in this course, we cannot take square root of negative numbers. So square root of minus 1 is taboo for us. So, as I said, all you need to make sure is the number inside the square root is non-negative, and this gives you an equation for x. So minus x plus 2 is greater or equal to 0. And now this minus x, you can put it on the right-hand side. So 2 is greater or equal to minus x, which is x. And therefore, what this gives you is x is less than or equal to 2. And that's precisely what the domain is. It's the set of numbers less than or equal to 2. And by the way, equal because it's okay to take square root of 0. It's not illegal. And the question is, what does that look like in terms of intervals? So again, we're including the number 2. And we kind of want to say all the numbers from minus infinity to 2. Now, remember, with infinity and minus infinity, you always put parentheses. So, parentheses, comma, minus infinity, all the way up to 2. And because we're including 2, we have to put this bracket. And that's it. Not too bad, hopefully. All right, next question. Okay, so this question is kind of combining what I said in the last two questions. Find a domain of f of x equals square root of x plus 8 over 3x minus 10. So again, what I said was, for square roots, you need to make sure that the number here is greater or equal to 0. So already let's try to figure that out. On the one hand, we need x plus 8 to be greater or equal to 0, and that simply gives us x is greater or equal to minus 8. On the other hand, for fractions, you need to make sure the denominator is non-zero. So you need to make sure that this is non-zero, and well, for this we can just solve for x. So 3x minus 10 is non-zero. What this means is 3x is not equal to 10, so x is not equal to 10/3, which is roughly 4.33333. 3.3333. Sorry. All right, and so we now have those two things, and we just need to combine them. So what is the domain? It's all the numbers greater or equal to minus 8. So you have minus 8 that you include here, all the numbers except for 10/3. Except for this thing here. And so notice here again, there are kind of two chunks happening. They're the numbers between minus 8 and 10/3. And they're the numbers bigger than 10/3. And so to write them in interval notation, what you want to say is, you start at minus 8, which you include. So minus 8, you go all the way up to 10/3, but which you exclude. That's how you write parentheses. Or you start with 10/3, which you exclude, and you go all the way up to infinity. And remember, infinity is parentheses. So that's how you write the domain in interval notation. All right, good. Enough with domains. Let's move on to lines. All right, next question with a little bit of lines. So we know a line passes through the point 8, minus 5 and has slope 3/4. Let's try to find the equation of that line in slope-intercept form, which just means write it in the form y equals to ax plus b. And again, there's this wonderful formula that just says y, to find the equation, you do y minus the y coordinate. So y minus minus 5 equals to the slope 3/4 times x minus the x coordinate. And all we need to do is just to solve for y and expand this out. So you get y plus 5 equals 3/4 x plus 3/4 times minus 8. But this junk here, we can just simplify, because that becomes 3 times minus 2. And that becomes minus 6. So what you have is y plus 5 equals 3/4 x minus 6. And then you just solve for y. So y equals 3/4 x minus 6. But now minus 5. And so in the end, you get the equation y equals 3/4 x minus 11. So indeed, this has slope 3/4, because again, the coefficient of x gives you the slope. And also, if you want, you can always double check if it goes to the point 8 comma minus 5 simply by plugging it x equals 8 and figuring out if it gives you y equals minus 5. And in fact, we can do this if we do 3/4 times 8 minus 5 minus 11, that I believe gives you 6 minus 11, which is minus 5. So indeed, this works. All right, that was a very neat line question. Let's do another one of the same sort. Let's do the next question. Find the equation of the following line, which I wrote very curvy, but it's supposed to be a line. And more important, it's a line that goes to two precise points, 5 comma 4 and minus 1 comma minus 6. And in order to do that, let's first figure out the slope. So the slope is just rise over run. So it's the difference between the y coordinates, which is 4 minus minus 6, divided by the change in the x coordinates. So 5 minus minus 1, and I believe that gives you 10/6, which you can simplify to 5/3. Okay? So already the slope is 5/3, and once you found the slope, you can easily find the equation of the line with the the equation for the line going through a point, namely. It's simply as follows. The equation then becomes y minus, let's say we choose this point, y minus the y coordinate 4 equals to the slope 5/3 times x minus the x coordinate. And then I believe you have to do it in, let's do it in slope intercept form. Then you just expand this out. Y minus 4 equals 5/3 x minus 5/3 times 5, which it does not simplify. Don't think you can cancel out the 5. And then you get y minus 4 equals 5/3 x minus 25/3. And then just add 4 to this, so y equals 5/3 x minus 25/3 plus 4, but then you can write this as 5/3 x minus 25/3 plus 12/3. Again, 4 is 12/3, and then minus 25 plus 12, that's minus 13. So you get y equals 5/3 x minus 13/3, which is quite a It's not a very nice equation, but one thing I also want to say, you can actually check if your answer is correct, because remember, again, the answer is this, but remember that to check your answer, you just need to check if your line actually goes through the point -1, -6. Which means that if you plug in -1 here, do you get y equals -6? So let's try that out. 5/3 times -1 minus 13/3. That becomes -5/3 minus 13/3, which is minus 18/3. And that's indeed -6, which tells you basically your answer is correct. All right, so we have arrived at a steep hill of our algebra marathon because the next 6 or 7 questions, they're word problems. And I know they look scary, but I want to show you they're not as scary as you think. So, question 9. Eric is draining an aquarium, and the following graph shows the amount of water in the aquarium versus time. So amount of water in liter versus time in minutes. And notice it is a line, so in some sense the amount of water is constantly decreasing. And the question is, first of all, what is the amount of water at 0 minutes initially? Well, 0 minutes, it just means look at the y-coordinate of 0. In other words, look at the y-intercept, which here is 90. So the amount of water initially is 90 liters. And the question is, if time increases, does the amount of water increase or decrease? Well, this is going down. So in fact, the amount of water is decreasing. So it decreases. And at which rate? So technically we would need to find the slope of this line, but essentially think of it as follows. If you increase it by 1 minute, you decrease the amount of water by 20 liters, right? Because this is going down by 20. So in fact, the rate at which it decreases is 20 liters per minute. Again, if you want to do it by rise over run, so 90 minus 7 is 20, divided by 1 minus 0, which is still 20. So it decreases that way. All right, again, next problem. All right, another word problem that it looks scary, but it's not that scary. So you start with a pond that has 600 liters of water, and suppose you're constantly adding water at the rate of 25 liters per minute. And the question is basically find an equation of the water in the pond in terms of the time, number of minutes that the water has been added. Now, because you're adding water constantly, this suggests that W is just a linear function of t. So W equals something t plus something else. Now, what is the first thing? It's just a constant rate that you're adding water in. So maybe let me add this here. W, in this case, the constant rate, which is 25 liters per minute. And then what is this other thing? It's just the initial number of water, because, 25t plus the initial amount of water, which is just 600. And that's your equation. Because again, this y-intercept represents the initial amount of water, and 25, that's the slope, or the rate at which you're adding water at. And lastly, how do you graph it? Well, I know on Alex you need like 2 points to graph it. So you start at t equals 0, which again is 600. Now, in the normal world, you would just need to plug in points, which means that if you add t equals 1, at t equals 1, W would be 25 plus 600, 625, but Alex doesn't really let you plot those points, so you just need to continue until you get a nice number. Because for t equals 2, you get 25 times 2 plus 600, so 650. I think it still doesn't let you plot. For t equals 3, you get 675. It's still ugly, but if you do t equals 4, you get 700, which is a nice number that you can plot. So you just click on 4, 700. Okay. And then the graph is just the line connecting 0, 600 to 4, 700. That's kind of how you plot it, yeah. All right, good. Again, it looks very scary, but I think once you see how to do it, it's okay. All right, next question. Another word problem that looks scary, but it's not that scary. So suppose Pablo is putting money in his savings account, and suppose the money he has is related to the number of weeks by the equation y equals to 350 plus 30x. And the first question is, what is the change per week in the money he has? Well, because this is of the form, a plus bx, it's a line, and in particular 30, which is the slope, tells you the rate of change. It tells you how much his money changes per week. And in particular, what this tells you is every week, like $30 get added. So $30 per week. In particular, it's increasing because this is positive. And the next question is, what is the starting amount he has? Well, it's given by this other number, 350. Because if you plug in x equals 0, this just becomes 350. So $350. All right. Okay. I know it's a word problem, but I don't think it's too bad. All right, next question. All right, another question. This time it is a word problem that's pretty bad, so pretty hard, I think. So suppose you're lighting a candle, and of course if you light the candle, eventually the height decreases, and suppose the height of the candle as a function of burning time is given by this beautiful line. And suppose you know the following. After 14 hours, the height of the candle is 19.4. So the line goes to 14, 19.4. And after 33 hours, the height is 11.8. So it goes to 33, 11.8. And the question is, what is the height after 25 hours? And there might be faster ways of doing this, but I think for me the easiest way is just figure out the equation of the line. So first, let's find the slope. So the slope is given, remember, rise over run. So here the difference between y coordinates, it's 11.8 minus 19.4. divided by 33 minus 14. Now 11.8 minus 19.4, it's minus 7.6. And then 33 divided by 14, it's 19. And it turns out if you use your calculator, you can simplify this to minus 0.4. All right, so here you have the slope, and then the question is, what is the equation of the line? Then you just use the usual trick of, y minus 19.4 equals minus 0.4 times x minus 14. Now, if you want, and this is what I highly recommend, since we know, since we want to find a value when x equals 25, it's totally fine to just plug it in here and then get the equation. But let me just be pedantic and let's do it the slow way. So y minus 19.4 equals minus 0.4x, and then plus 0.4 times 14. okay, which gives me the following: 0.4 times 14, 5.6. So y minus 19.4 equals minus 0.4x plus 5.6. And then we get the following. So y equals minus 0.4x plus 5.6 plus 19.4, which I believe is 25. So y equals minus 0.4x plus 25. So that's the equation of the line. And now we just need to plug in x equals 25. So y equals minus 0.4 times 25 plus 25. And I believe that's just 10, minus 10. So y equals minus 10 plus 25, and that's 15 centimeters. And that's the answer. Right? The height after 25 hours. All right, good. Move on to the next question. Okay, now question 13, and believe it or not, we're only a quarter done. And yeah, and by the way, I've already spent an hour recording. It's kind of crazy. But this one is another juicy word problem. So suppose a family has 2 cars. The first car has a fuel efficiency of 15 miles per gallon, meaning that for every gallon of gas, that car can drive 15 miles. And the second car has a fuel efficiency of 20 miles per gallon. Now, suppose that in a week, the 2 cars combined drove a total of 825 miles, and combined, they consumed 45 gallons of gas. The question is, how many gallons were consumed by each car? Now, because you see the word by each car, what this means is you need to label the gas in each car by a variable. So let A be the gallons, if you want gallons in car A, in car 1, sorry, and B be the number of gallons in car 2. In car 2. And the idea is as follows. Now look at every piece of information and let's try to write this in terms of equations. Now car 1 is 15 miles per gallon. That is kind of a rate, which we'll talk about in a second. Car 2, it's 20 miles per gallon, which is another rate. And here comes the interesting fact. We know that the total distance was 825 miles. Now, how do you calculate the total distance? Well, it's the distance of car 1 plus the distance of car 2. So we know the total distance is 825 miles. But the question is, how can we calculate the distance of the first car in terms of the number of gallons? Well, remember the fuel efficiency of the first car was 15 miles per gallon, which is like a rate in some sense. So in order to figure out the distance of the first car, take the fuel efficiency, the rate, and multiply it by the number of gallons, which was A. So on the one hand, we have 15A. That's again the distance that the car drove. And for the second car, it's the same thing, except we had 20 miles per gallon. Almost think of it as like 20 miles per hour, and this is the number of hours that the car drove. So the total distance here is 20b. That's already very good. It gives us one equation. And the second equation is much easier. It tells you that the total gas consumption is 20 gallons. So if you add the gallons in A and the gallons in B, you get 45. So literally the second equation is just A plus B equals 45. And now you could solve, this is a system, you could solve it with elimination if you want, but in my opinion it's easier just to solve for by substitution. So let's do b, it's 45 minus a. So what we get is b is 45 minus a. And by the way, you could simplify this a little bit by dividing by 5, but we don't even need to do that. So 15a plus 20 times, again, now plug in b equals 45 minus a in this equation. So 20 times 45 minus a equals 825. And then we get 15a plus, let me check, 15a plus 900 minus 28, that's 825, and we can simplify this, so minus 5a plus 900 equals 825, so minus 5a equals 825 minus 900, which is just minus 75. And therefore, a is just minus 75 divided by minus 5. Okay, and I believe, if I'm not mistaken, it's a 15. Yeah, it is 15. So A has 15 gallons of gas, and then let's ask for B. Well, for B, we'll just use this thing. Okay, B is 45 minus A, m to the v, m to the v, and then so it's 45 minus 15, and that's 30. Very good. And if you want, you can even check if your answer is correct simply by plugging in a equals 15 and b equals 30 and figuring out if it's 825. So again, the answer is a is 15, b is 30. All right, next question. Okay, question 14. So suppose you're, Chef Gordon Ramsay. It's raw, and you want to make a salad dressing. And suppose you're given two brands. Brand 1, which only has 9% vinegar, and brand 2, which has 14% vinegar. And suppose you want to make, in total, 200 some dressing that is 290 milliliters, but 12% vinegar. And the question is, how much of each brand should you use? So again, the question is about each brand. So let A be the volume, if you want, or the amount of brand 1. And then B be the amount of brand 2. Of brand 2, and then let's try to calculate again, the number of vinegar and also the total amount. So the total amount in the dressing is 290. So it already tells you that A plus B is 290. Right? If you add this brand and this brand, you should get 290, which is super useful. And we also know that the total amount of vinegar is 12%. Now, how do you get the total amount of vinegar? One way of doing it, it's simply 9% of the first brand, so do 0.09 of A, and add it to 14% of the second brand, so 0.14 B, and that in the end should give you 12% vinegar. So 0.2 times the total amount, but here we were kind of nice. We told you that the total amount is 290. So 0.2 times 290 is 34.8. So the cool thing is here we actually have two equations that are pretty easy to solve. So what we have is a plus b equals 290 and 0.09a plus 0.14b, it's 34.8. And the cool thing is you can use the same technique as the previous problem to solve this, because if a plus b is 290, b is 290 minus a. And then this equation you can just plug in to here. And what you end up getting is the following. 0.9a plus 0.14 times 290 minus a equals 34.8. And then this you can expand out. So 0.09a plus, so 0.14 times 290, let me calculate that. That's 40.6. And then minus 0.14a. Again, here I just did 0.14 times 290 minus 0.14 times a, and that gives you 34.8. And then you can simplify this a little bit. So I believe, I know such weird numbers, but if you do 0.09 times a minus 0.14 times a, you just get minus 0.05 times a, and that equals 34.8 minus 40.6. So minus 5.8. So minus 0.05a equals minus 5.8. So a is just minus 5.8 divided by that 0.5, and again it's the same thing as minus 5.8 over times 20 if you want, 0.05, and I believe that gives you 116. So the amount of dressing that you should, of the first kind that you should use is 116. And the question is, how do you get b? You just use the second equation. So b is 290 minus a. So 290 minus 116. And that gives you 174. And again, you can always check your answer by plugging into the second equation and see if it gives you 34.8. Let me just double check. Yes, okay, that's correct. And again, don't forget the units, milliliters and milliliters. All right. Okay, next problem, a little physics problem. So suppose you have a plane that travels 1,400 kilometers against the wind. So suppose this is a plane that kind of looks like a goldfish, and suppose if it travels against the wind, so with some resistance, so it's a little bit slower, then it travels only 1,400 kilometers against the wind. But suppose, and in 2 hours, and suppose with the wind, so if you're gone with the wind, or if you're flying with the wind, it can travel 1,580 kilometers in the same time. And the question is two things. What is the rate of plane still in the air, so without any wind, and what is the rate of the wind itself? So because we're asking for two variables, let's just call them by their names. So the rate of the plane still in the air, let's call it P, and the rate of the wind, let's call it W. Now, here what we need to use is the equation rate equals distance over time. In fact, we need to do it twice. On the one hand, and maybe let's do the easier part first. So what does that 1580 kilometer with the wind in the same time tell us? Well, what is the rate of the plane with the wind? It's simply the rate of the plane and you're adding the velocity of the wind. So what this tells us is the following. So this is the second equation if you want. If you add P and W, so this rate is the same thing as the distance, 1580, over time, which is 2 hours. So in the same time means in 2 hours, and then 1580 divided by 2, 790. And maybe a little bit harder. So what is the rate of the plane against the wind? Well, it's the rate of the plane, but this time you have to subtract the rate of the wind. So P minus W, because it goes much slower. And that is 1400 divided by 2, which is 700. So now you have two equations, which actually you can easily solve for. So now you have P minus W equals 700 and P plus W equals 790. Now, you could use substitution, but here elimination is much easier, which means here you can either add or subtract the equations. Both would be correct, but here let's add them to get rid of this minus W. So what we get is P plus P, so 2P, and then minus W plus W, that cancels out, equals 700 plus 790, which is 1490. Okay. And therefore 2P is a 1490. So P is 1490 divided by 2, which I believe gives you 745 kilometers per hour. Or did they use miles? No, kilometers per hour. The good units, okay? So that's the rate of the plane. Okay. So P is 745 kilometers per hour. And the question is, what's the rate of the wind? So there's two ways of doing this. Either subtract those two equations, that would also work, or simply use the second one. So P plus W equals 790, which tells you that W is 790 minus P, and we found P, so 790 minus 745, and that gives you 45. So in fact, the speed of the wind is just 45 kilometers per hour. Quite a big wind, I would say. And you can always check here if you're adding the two equations, you indeed get 790, and if you're subtracting it, you get 700. So this is correct, and I'm cool like that. All right, next question, and that will be the last word problem, at least for now. All right, next question, hopefully one of the last word problems. But so basically a theater group is visiting, hotels in two cities, and suppose the second hotel before tax is $1,000 more expensive than the first hotel, and suppose the tax rate in the first one is 4%, the tax rate in the second one is 8%, and the total tax paid is $710. And the question is, how much is each hotel before tax? Okay. So again, because we're talking about each hotel, let A be the price of hotel 1 before tax, and B be the price of hotel 2. Now, the nice thing is, this already tells you a little bit of information. We know that hotel 2 is $1,000 more expensive than hotel 1, so B equals A plus 1,000. So we'll need that. And again, the hotel 1 tax rate is 4%, the hotel 2 tax rate is 8%, and the total tax is 710. Now, let's think of how to calculate the total tax. On the one hand, it's 710. On the other hand, the way to get this is you add the tax paid in hotel 1, which is just 4% of whatever you paid, so 0.04A, and 8% of what you paid in hotel B. So if you add those two up, you get 710, and that is your second equation. And now you can easily solve for A and B, because you're also given that B is 1,000 plus A, which now you can just substitute. So you have this thing here, so you get 0.04A A plus 0.08 times 1,000 plus A equals 710. Okay, and now you can just solve this for A, so we get, like Fonzie says, A. All right, and then you get 0.04 A plus, so you just expand this out, so 0.08 times 1,000, I believe that's 80, okay, and then plus 0.08 A equals 710, okay, and then if you add this and this, you get 0.12A equals 710 minus 80, and again, just to make sure, equals 630. Oh, no, it's only 530 now, but yeah, 630. And so again, 0.12A equals 630, which tells you that A, it's 630 over 0.12, which is 5,250. So the charge in the first hotel in the first city was $5,250. And how do you get the charge in the second hotel? You're just adding 1,000 to that. So it becomes 1,000 plus 5,250, which just becomes $6,250. All right, I believe that's it for that. Okay, good. And this ends the word problems for now. I know, pretty long, but now let's move on to more fun stuff. All right, so now we're running back downhill and it's a lot of fun. So suppose you have the graph of this function h, and the question is, so what are the local maxima of h, and also at which values are those local maxima attained? Local maxima, it just means hills or peaks of this function. So this function h, notice it goes up to 3, and then it goes down. So it has this little peak at the height 3. And it's very important to understand the local maxima themselves, they're the heights. So here it has the height 3, and then it goes down at this local minima, and then it goes up again at this peak, which is 4. So the local maxima here are 3 and 4. And the question, at which values does h attain the local maxima? It just means at which values is there a peak. So we saw that the peak here is 3, and it's attained at -2. So we can already say -2. And then there's this other peak at 4, and it's attained at 2. So here it's -2, 2. Much easier than the word problems. All right, let's move on. All right, next question, another fun and quick one, except it took forever to draw this. So the question is, suppose you're given this function g. And what is the absolute maximum and the absolute minimum? And you have to understand, absolute maximum means the biggest possible value. And in particular, it needs to be attained. And I explain what that means. So here, if you think of this as a mountain, the biggest possible value here is 3. So, and it is attained because you can reach it using -2. So the absolute maximum is 3. The question is, what is the absolute minimum? You might first guess that it's this point, but look at what this graph does. So it goes up, down, up, and then it goes down up to -infinity. And very important, if you have an absolute minimum or maximum, that value must exist. So infinity and -infinity, they're never absolute maximums and minimums. So here we just say there is none. Okay, because again, this blows up to -infinity. All right, what about here? So that's quite interesting actually. So it starts up here, it goes up to here, but careful, this cannot be an absolute maximum because it's never attained. There's actually no value for which, at least around here, for which this function is, let's say, 2. But it doesn't matter because, in fact, there's an even bigger value soon. So it goes up and it goes down, and this is really the smallest point. So this is actually the absolute minimum at -4. And it is attained because you can reach it using the value 2. And then it goes up, up, up to the biggest point here, which is 3. And this is, in fact, the absolute maximum. So the biggest point of the function. All right, hopefully not as bad as the word problems, but let's move on. Next question. So suppose g of x is x squared plus 9. The question is, what is g of x? So, giggity, Anyway, this is g of x. And all this means is the following. And in fact, let me use color here. It just means take the definition of g, but whenever you see x, replace it with g of x. So here it's not x squared plus 9, it's g of x squared plus 9, which is basically x squared plus 9 squared plus 9. And then you expand this out using, a squared plus 2ab plus b squared. So x squared squared plus 2x squared 9 plus 9 squared plus 9. And that gives you x to the 4th plus 18 x squared plus 81 plus 9. And that gives you x to the 4th plus 18 x squared plus 90. So that's giggity, and now let's do ha ha ha. So now let's do h of x. Okay, so now h of x is 2 over 9x, and now let's do ha ha of x. So that's h of x. And what this means is take the definition of h, but replace x with h of x. So this becomes 2 over 9, not x, but 2 over 9 h of x. And that becomes 2 over 9 times 2 over 9x. And 9 cancels out, I believe, and you get, or maybe let me do it a bit slower, 2 times 9 times 2 over x 2 over 9x, and that becomes 2 over 9 times 9x over 2. Okay. This cancels out, and you end up getting x. Okay. And by the way, I mean, it's not part of the problem, but because you find h of x equals x, it means h is its own inverse, which is quite neat. All right, next question. All right, another fun composition question. Given that f is x plus 2 over x minus 1 and g is 2x minus 3, let's find f composed with g of x. So same idea as before. So by definition, this is f of g of x, and all it means is whenever you see x, replace it with g of x. So that becomes g of x plus 2 over g of x minus 1. And what this becomes is just 2x plus 3, so 2x minus 3, plus 2 over 2x minus 3, and then minus 1. And that becomes, so 2x minus 1 over 2x minus 4. That's all we can do. And the question is, what is the domain? If g is not defined at the point, then you would have to be a little bit careful. But because g is defined everywhere, it's enough just to look at the domain of the resulting function. So you just need to check when the denominator is non-zero. But look, if 2x minus 4 equals 0, this tells you 2x equals 4, and so x equals 2. So the domain would mean x is not equal to. And so the domain is, again, all the numbers except for 2. And again, the way to write this is simply as follows. There are two pieces here. It's the interval minus infinity comma 2 or 2 comma infinity. And again, parentheses, because you're excluding 2. All right. Okay, next question. You see, not that bad. Okay, next problem. It's a word problem that's actually super quick. So suppose the area as a function of radius is pi r squared, so a circle. And suppose the radius as a function of time is 14/3 t. The question is, what is the area as a function of time? And all they really ask you to do is to compose the two things. So the area z of t as a function of time is just a of m of t. And again, all this means is replace r in pi r squared with m of t. So it becomes pi m, okay, pi m t squared, and that's pi times 14/3 t squared. This it don't simplify, so that's it. I know, we're very awkward problem, but all right, next one. Now the next couple of questions are quick, like quadratic functions questions. So let's solve 6x squared minus 18x equals 0. Again, this one is easy enough that you can just solve it directly. So let's factor out x. So x times 6x minus 18 equals 0. You could factor out 6 from this, but it's not even necessary. And now the product of two things equals 0 if and only if one of them is 0. So this tells you either x equals 0, so either this is 0 or this is 0, or 6x minus 18 equals 0, so 6x equals 18, so x is 18 over 6, which is 3. So there are two solutions here, 0 or 3. Good. All right, next question. Okay, so the next question, again, quadratic formula. Solve v squared minus 4v minus 21 equals 0. Now, if you want, you could just factor it out, completely fine, but let's just use a quadratic formula for this. So notice this is of the form av squared plus BV plus C, where B is minus 4, and C is minus 21, and A is 1. So again, what does the quadratic formula tell you? V is minus B plus or minus square root of B squared minus 4AC over 2A. Okay. And what this becomes is, so just got to be very careful, minus 4 plus or minus square root of minus 4 squared minus 4 times 1 times minus 21, okay, over 2 times 1, so over 2, by the way, forever minus 21, and that gives you 4 plus or minus square root of 16 plus, so 4 times 24, that becomes 84 over 2. And then let's see what this becomes. This becomes 4 plus or minus, so that simplifies quite nicely, square root of 100 over 2. So it's 4 plus or minus 10 over 2. So it's either 4 minus 10 over 2 or 4 plus 10 over 2. And that's, so minus 6 over 2 or 14 over 2, which is minus 3 or 7. So the answer is 3 or minus 3 or 7. Again, you could have just gotten from factoring out, but this is more systematic in my opinion. The next question, let's solve for u in the following equation. 4u squared equals minus 9u minus 2. So this gives you 4u squared plus 9u plus 2 equals 0, which is of the form au squared plus bu plus c, where a is 4, b is 9, c is 2. And for this, let's just use a quadratic formula, which tells you that u equals minus b plus or minus square root of b squared minus 4ac over 2a, which in this case just becomes the following. So this is minus 9 plus or minus square root of 9 squared minus 4 times 4 times 2 over 2 times 4. Now, let's simplify this a little bit, and that becomes minus 9 plus or minus, so let's say 81 minus, so 4 times 4, that's 16, times 2, that's 32, over 8. And that becomes minus 9 plus or minus, so 81 minus 32, 49 over 8. And that becomes minus 9 plus or minus 7 over 8. And let's simplify this. So, and that equals either minus 9 minus 7 over 8 or minus 9 plus 7 over 8, and minus 9 minus 7, that is minus 16, or minus 2/8, and minus 16/8, that's minus 2, or minus 1/4. All right, congratulations, we're halfway done. So let's move on. All right, next question, super quick. Let's find the zeros of the following function. Well, for those, if a polynomial is factored out, a polynomial is 0 if and only if one of those factors is 0. So we either get 5x equals 0, or x minus 16 equals 0, or x minus 3 equals 0, which simply tells you that either x is 0, or x is 16, or x is 3. So there are 3 zeros here, 0, 3, or 16. Not bad at all, I think. All right, next question. Next question, I think equally easy. So find the zeros of the following polynomial with multiplicities. So all this means is, same thing as before, find the zeros, but just count the number of times it gets repeated. So again, a polynomial is 0 if and only if one of the factors is 0. So we get either x equals 0, but because of this exponent 2, it tells you that the multiplicity is 2. Or x minus 8 equals 0, which tells you x equals 8. And again, with multiplicity 2, because we have this exponent 2 here. Or x plus 6 equals 0, which tells you x equals minus 6, but this time with multiplicity 3. And that's it. Yep. All right, next question. All right, next question, pretty in pink. Find a quadratic function with zeros 5 and minus 7. So this is the easiest question of the day, actually. To find a quadratic function with zeros 5 and minus 7, you just do x minus 5 times x minus the root minus 7. And then this just becomes x minus 5 times x plus 7. And then you just FOIL this out. So x squared plus 7x minus 5x, and then minus 5 times 7, so minus 35, and then you're left with x squared plus 2x minus 35. Yeah, that's it. You see, much better than a word problem. Okay, next question. Let's move on to a little bit of exponential stuff. So suppose the population of a certain species as a function of time is 450 over 1 plus 5 e to the minus 0.29t, where t is time. Then this gives you, again, population with respect to time, so p of t, not Payam of Tabrizian, that's something else. And the question is, well, what is the initial population size? All this means is plug in t equals 0 in this formula. So for t equals 0, we get 450 over 1 plus 5 e of minus 0.29 times 0. So e of 0, but e of 0 is 1. So it's just 450 plus over 1 plus 5 times 1, and that's just 5. And so in the end, the answer is 450 divided by 6. And I calculated that becomes 75. So the initial population size is 75, and the question is, what is the population size after 9 years? You just plug in t equals 9 here. So the answer here would be 450 over 1 plus 5 e of minus 0.29 times 9, and that becomes 450. Das gibt's 450. So 1 plus 5 e to the, let's see, I calculated that, minus 2.61. And then if you calculate this, this gives you roughly 329.03 individuals. But it doesn't really make sense to say you are 0.03 of an individual, so just round it down to get 329. Okay. All right, good. Next question. All right, next question, again, a finance problem a little bit. So suppose you're taking a loan at an interest rate of 3% that is compounded continuously, and suppose initially your loan is 1,400. The question is, how much is owed after 2 years? Well, for this we need to use a formula for continuous compounding, which is just PERT. So the amount owed after t years is P e to the RT. By the way, little funny story. I once took a shower and there was a shampoo next to me called PERT. And that's all I could think about, continuous compounding. Now, what are all those letters? So P is the initial amount, so 1,400. E is Euler's number, again very important. And then R is the interest rate, so 3%, which is 0.03. And T is the time in years, so here 2. And so in the end, the answer is 1,400 times E of 0.06, and we can calculate that times E of 0.06. And that's roughly, in terms of cents, that's roughly $1,486.57. This is how much you owe after 2 years, provided you don't make any payments. All right, very good. All right, next question looks very different, but actually super similar. So suppose you have a radioactive substance, like the Imagine Dragon says, radioactive. And suppose it follows an exponential decay model, and suppose the initial mass is 6,958 kilograms, and which is my mass after this quarantine, and it decreases continuously at a rate of 19% per day. The question is, what is the mass after 3 days? So here we just have to be careful. So it's still PERT, but there's a major difference you'll see in a second. So P is the initial thing, so 6,958. E is Euler's number, okay, so E. And then R, be very careful, because you might guess that R is 19%, so 0.19. But that would assume it increases. Because it's decreasing, you have to make sure it's negative. Because otherwise it would mean it just grows at 19%, which is not what we want. And then finally the mass after 3 days, so T is 3. Okay. And then in the end, that gives you 6,958 E of, so minus 0.19 times 3. So minus 0.57. And then you calculate that 3,934 kilos, 0.9. Okay. And very important, always make sure your answer makes sense, because here the initial mass is roughly 7,000 and it went down to 4,000. So indeed it decreased. Suppose you found like 10,000. Then that wouldn't make sense in this problem, because we're saying it's decreasing, not increasing. And in that case, your mistake was probably in the sign here. But other than that, again, compare it to the interest rate thing, basically the same. All right, let's move on. All right, so the next couple of problems, it's like a downhill run. So just some chill exercises with logs. So let's simplify log of x to the 7th divided by z times cube root of y squared. And for this, you first use the first property of logs, which says log of a over b. It's the same as log of a minus log of b. So this is the same thing as log of x to the 7th minus log of z cube root of y squared. Okay. That's one thing. And then, in my opinion, the most important property of logs is that if you have log to x to the something, that something comes down. So you're left with 7 log to x. And here what we use the product property of logs. So log AB is log A plus log B. So here you have minus log of z plus log of cube root of y squared. I hope you're not logging off after this video. And then you can expand this out. So 7 log x. Okay. And then minus log z. And then minus log of this. But this is kind of ugly. It turns out we can simplify it, because cube root of y squared, it's like y squared of the 1/3 power, and that's y to the 2/3. So it is the same as y to the 2/3. And last but not least, same property as here. If you have log of something to the something, you can pull the exponent down, and you're left with 7 log x minus log z minus 2/3 log y. And you see, this in my opinion is a little bit nicer than the original expression, but again, both things are nice in some sense. All right, next question. All right, next question, the reverse of the previous question. So here you have this big expression, and let's write it as a single logarithm. And here it turns out this m doesn't matter at all. So it could be log base 10, log base 2, whatever, okay? And here what we would like to do, so you have a constant times a logarithm. Now pull the constant as an exponent. Because remember, log of, let's say, w to the something becomes that something log of w. So what you're left with here is log base m of w to the 5th. Okay? And same thing here as well. So this becomes minus log base m of z to the 1/4. And then one more time, plus log base m of y cubed. And then let's first of all focus on this expression in the left. So here we want to use that log a minus log b is log a over b. So this becomes log base m of w to the 5th over, well, z to the 1/4, that's just 4th root of z. Okay. And then plus log base m of y cubed. And lastly, let's use the fact that log a plus log b is the same as log of the product. So this becomes log base m of w 5th times y cubed over 4th root of z. So here I just took the product of the two. So w 5th times y cubed divided by 4th root of z. And that's it. You know, how nice. And you know, if you're watching in December, well, it's almost holidays, where you have a holiday log. This is my holiday log for you. Okay, so let's simplify a couple of logs again. So let's do 2 log base 3 of 4 minus log base 3 of 48. So again, same property as before. 2 log base 3 of 4. You can put this as an exponent. So that becomes log base 3 of 4 squared. And then minus log base 3 of 48. Okay, so it becomes log base 3 of 16 minus log base 3 of 48. And then the difference of logs is like log of the ratio. So this becomes log base 3 of 16 over 48. Okay, and that becomes log base 3 of 1/3. And if you'd like, that's the same thing as log base 3. So we want to write 1/3 as 3 to the something, because that's what log works, makes log work. And the question is now, which power do you have to raise 3 to get 3 to the minus 1? Well, the answer is precisely minus 1. And if you do not like this, you could also do, put this down in the exponent, so it becomes minus 1 log base 3 of 3. But log base 3 of 3, that's just 1. So in the end, you get minus 1. Again, two ways of doing it. You always think 3 to the what is 1/3, and it's minus 1, or use this property of logs. So that was the first part of the question. Now let's do the second part. So here, let's calculate ln of e cubed plus ln of e to the 7. Well, you could either directly say it's 3 plus 7, or if you don't like this, let's use the multiplication property. So it's ln of e cubed times e to the 7, and that becomes ln of e 3 plus 7, and that's ln of E10. And again, what is this? It's the number. Again, ln is just log base e. So it's the number that you have to raise e2 to get e to the 10. So you can either directly say 10, or again, use this power property of log that says it's 10 ln of e. But ln of e is just 1. So in the end, the answer is 10. Kind of fun problem, in my opinion. All right, next question. All right, so next question, let's solve this exponent equation. So 5 to the y minus 3 equals 2. So basically what we want to use logarithms to destroy this equation in some sense. And it absolutely doesn't matter which logarithm you use here, as long as in the end you get the correct answer. So let's use my favorite one, which is ln. So let's do ln, like, ln degenerate, ln of 5 to the y minus 3, that's ln of 2. Okay. And then the nice thing is, this y minus 3 pops out, and you get y minus 3 ln of 5 equals ln of 2. And so then you divide by ln of 5, so y minus 3 equals ln of 2 over ln of 5, which tells you in the end y equals to ln of 2 over ln of 3, or ln of 5 plus 3. Roughly 3.43. And again, it doesn't matter if you use ln base, log base 5, log base 10. In the end, you all get equivalent answers. All right, similar question. So let's solve for x in e to the 8x equals 2. So let's again destroy it with ln. So ln of e to the 8x equals ln of 2. And you could directly say it's 8x, but in case you're not comfortable with this, just pull this down. So 8x times ln of e equals ln of 2. Now ln of e, that's just 1, and then you end up with 8x equals ln of 2, which tells you x equals ln of 2 over 8. And I believe it's calculated this is roughly 0.09. Okay, very good. One more equation with x, so for solving logarithms. Let's solve for x in 17 to the 7x equals 16 to the minus x plus 6. So again, destroy this equation with logarithms. So do ln of 17 to the 7x equals ln of 16 to the minus x plus 6. And then the nice thing is this 7x comes down, and this minus x plus 6 also comes down, and you're left with 7x ln of 17 equals minus x plus 6 ln of 16. And it's kind of ugly, so you do have to expand out this equation a little bit. So we get 7 ln of 17x equals, if you want, minus ln of 16x plus 6 ln of 16, and then just put the x on the left hand side to go with this one. So 7 ln of 17 x plus ln of 16 x equals 6 ln of 16. And the nice thing is x factors out, so 7 ln of 17 plus ln of 16 x equals 6 ln of 16, which tells you in the end that x is just a ratio, so x is 6 ln of 16 over 7 ln of 17 plus ln of 16. Okay, roughly 0.736. All right, that was enough ln equations. Let's speed up a little bit and let's do a little bit of graphs because they're fun. Okay, so here a very fun problem. So I give you 3 graphs and you have to answer, is this symmetric about the x-axis? Is this symmetric about the y-axis? Or is it symmetric about the origin? Or maybe all of those. So what does symmetric about the x-axis mean? It means that if I flip this across the x-axis, you get the same graph. Unfortunately, if you flip this across the x-axis, you do not get the same graph. So it's not symmetric about the x-axis. Y-axis, same thing. If you flip it across the y-axis, you should get the same graph. Unfortunately, you do not. So if you flip this blue thing, you do not get this blue thing back. No. Lastly, if you flip it about the origin, so think of this as the point of reference, and you flip everything about the origin, you should get the same graph or not. So here, well, let's see. If you flip this point here, you're back on this graph. If you flip this point here, you're on this graph. If you flip this point, you're on this graph. So it seems that if you flip everything across the origin, you do get the same graph back. So in fact, here the answer is yes. Okay? So it is symmetric about the origin. What about this thing, this circle? Well, if you flip the circle across the x-axis, you still get the same circle. So yes. What about the y-axis? If you flip this across the y-axis, you also get the same circle. Or think of it almost like folding, right? If you fold those two things, they should be the same. And lastly, how about the origin? Well, if you flip the circle across the origin, you still get the same circle. So interestingly here, all those symmetries are valid. Last but not least, what about this parabola in some sense? Then if you flip it across the x-axis, interestingly you get the same parabola. So yes. What about the y-axis? If you flip this across the y-axis, you actually get this parabola here. So no, it's not symmetric across the y-axis. Lastly, what if you flip it across the origin? Well, it turns out you actually get this parabola again, which is not the original one. So no, it's also not symmetric across the origin. So here we have the symmetry across the origin. Here it's like perfectly symmetric, and here it's just symmetric across the x-axis. All right, next question. Another fun, like fill in the blank question. So suppose I give you the graph of this function, and all you have to answer is between each point, is the function increasing, decreasing, or constant? So between a and b, the function is going down. So it is decreasing here. Between b and c, it doesn't really change. It doesn't go up or down. So in fact, here it's constant. Okay. And then between c and d, it's going up, so it's increasing. And between d and e, it's constant again. So what you get is decreasing, constant, increasing, constant. Okay. And here by increasing, we mean like strictly increasing. Not bad at all. Maybe the easiest question of this marathon. All right, next question, similar in nature, but a little bit more complicated. Suppose I give you the graph of this function f, not drawn to scale, and the question is, where is f strictly increasing? So in other words, where is f strictly going up? Now, between -7 and -6 is constant, so not increasing. But then, between -6 and -3, it is increasing. So already we can say it's -6, -3. And here, I don't think it matters too much if you use parentheses or brackets, but just to be safe, use parentheses here, because strictly speaking, at this point, it's not really increasing. And then, between -3 and -1, it's constant, so we ignore that. Between -1 and 1, it's decreasing, so certainly not increasing. But then between 1 and 5, it's increasing again. So you want to say something like either -6, -3, or 1 to 5. And to say or, we just use that union sign. And that's it. So again, always look where this function is going up. All right. All right, next question, almost done. So, I mean, not almost, but we're like in the 40s now. So just find the average rate of change of the function -3x² plus 10 from -4 to 1. Now the formula for average rate of change is very easy. It's just g of the endpoint minus g of the starting point divided by end minus start. So in this case, the end point is 1, the starting point is -4, so it's g of 1 minus g of -4 divided by 1 minus -4. So make sure the denominator is positive here. And what this becomes is just -3 times 1 squared plus 10, and then minus -3 times -4 squared plus 10, and all this divided by 5. And now careful about the algebra. So it is college algebra after all. So just beware of algebra mistakes. So here, -3 times 1 squared, that's -3. And then plus 10. And then here, minus becomes plus. So plus 3 minus 4 squared, that's -4 times -4. So that's 16. And then minus 10. And all this divided by 5. And here's the nice thing. The 10 and -10, they cancel out. And I believe you get -3 plus 3 times 16, 48 over 5. And that becomes 45 over 5, which is 9. Or in German, they say no, right? Or all right. Yeah, great. Next question. Okay, same question, but here it's just with a graph. So let's find the average rate of change of this function f from -2 to 4. So I would like to remind you the formula is f of end minus f of start over end minus start. And here it becomes f of 4 minus f of -2 over 4 minus -2. And then you just have to read off the graph what the values of the function are. So here f of 4 is, I believe, -9. And then f of -2, it's 3. So -9 minus 3 over 4 plus 2. And I believe that becomes -12 over 6, and that's -2. So that's it. It's just this formula. F of end minus f of start over end minus start. All right. Final sprint, almost done. Okay, suppose that f of x is 3x squared minus 3, and again, this is the algebra sprint now. Find f of x plus h minus f of x over h, where h is just a given non-zero number. And this will be very important, by the way, if you take calculus. So here, all you have to do is evaluate every single expression. So f of x plus h is just f of x, but you replace x with x plus h. So it's 3 times x plus h squared minus 3, and then minus f of x, so minus 3x squared minus 3 over h. And for this, now expand out this x plus h squared. So this becomes 3 times x squared plus 2xh plus h squared minus 3. And then expand that out, minus 3x squared plus 3. So this cancels out. And then divide by h. And then we get a 3x squared plus 3 times 2, so 6xh plus 3h squared, and then minus 3x squared over h. And if you take calculus, you'll see it's magical. Like all those beautiful formulas simplify. So the 3x squares cancels out, and you're left with 6xh plus 3h squared over h. But the nice thing is you can actually factor out h at the top. And so what you end up with is h times 6x plus 3h over h. Again, because it's h times 6x and then h times 3h. And this cancels out, and you're left with 6x plus 3h. And that's it, I think. Yeah. All right, next question. Next question, so very simple. Write e cubed equals h as a logarithmic equation, so with logs. And all you need to do is take e cubed equals h and apply ln to this, because ln is very nice with e. So ln e cubed equals ln of x. But now you can either immediately say it's 3, or if you're not comfortable with this, put the 3 down, and you get 3 ln of e equals ln of x. Ln of e, it's 1. And so in the end, this becomes 3. So 3 equals ln of x. Or you can just write ln of x equals 3. I think that's all they want to do. And just do something very similar now. So now just write ln of 7 equals y as an exponential equation. So here we have ln of 7 equals y, and it literally tells you what to do. So since we want to write this as an exponential equation, let's raise both sides of the equation to the power of e. So do e to the ln of 7 equals e to the y. And the nice thing is, e of ln just cancels out. So that's the definition of ln, actually. And then you just get 7 equals a. Or if you want, a equals 7. How cool is that? So I think a very nice exercise with logs and exponents. All right, next question. Right. 2 very quick questions. The first one is evaluate log base 6 as 1 over 36. What this means is you have to write 1 over 36 as 6 to the something. Okay? And for this, just do it by step. So log base 6 of, so 36 is just 6 squared. And therefore, this becomes log base 6 of 6 to the minus 2. And again, the question is, which number you have to raise 6 by to get 6 to the minus 2. So the answer here is simply minus 2. But if that doesn't make you comfortable, you can also write it as minus 2 log base 6 of 6, which is 1, and in the end you get minus 2. So that's the first part. The second part, very similar. Second question is simply, what is log base 4 to the 6 of 64? So all you need to do, you need to write 64 as 4 to the something. But if you want 64, that's 4 times 16. And that's 4 times 4 times 4. And that's 4 cubed. So log base 4 of 64 becomes log base 4 of 4 cubed. And again, with a similar technique as before, you can just say that this is 3. Ta-da. Again, very nice math quickie. And now let's move on. The next 3 sub-problems is again a fun exercise with logarithms. So first, the first question is, what is log base 8 of 3 plus log base 8 of 7? So just use the properties of logs. So that's log base 8 of 3 times 7, which is log base 8 of 21. So that's the first number you have to enter if you want. Second question is, log base 9 of 8 minus log base 9 of what is log base 9 of 8 sevenths? Here you use the second property of log that says this is log base 9 of 8 minus log base 9 of 7. So log of a ratio is like the difference of logs. So this becomes 7. And last question is, log base 5 of 25, it's equal to what? Log base 8 of 25 is what times log base 8 of 5? Well, notice this is log base 8 of 5 squared, and then the 2 just comes down. So it's 2 times log base 8 of 5. Okay. All right. Okay, a very nice quickie, and I am racing against the sun because it's starting to become very dark, but I am almost done. All right, 3 more questions left. The only issue is there are 3 word problems, so it's really the final sprint. So the question here is, $7,000 are placed in a savings account at an annual rate of 5.6% interest, compounded semi-annually, so twice a year. And the question is, how long will it take to reach $8,036? So here, careful, you do not use the PERT formula, because that would be compounded continuously. Because it's compounded semi-annually, you have to use a slightly different formula, which is simply P, so your initial money, times 1, again to make it grow, plus your interest rate, okay, but divided by the number of times you compound it, which is 2, or in general n, and then times to the power of 2t. So careful, here you do not use the PERT formula because that would be for compounded continuously. Here we want to compound it twice per year, so we have to use the following formula, P times, again, your initial value, your initial money times 1 plus, to make it, grow, your interest rate divided by the number of times you compound it, so here 2, and to the n, so how many times you do it per year, times the time that you want. So in this case, it becomes the following. So let me explain. Your initial money, it's 7,000. And then to make it grow, you put a 1. And the idea is you take your interest rate, which is 0.056, and instead of telling you I give you 5.6% directly, I'm telling you we just split it up into 2. So that's why you divide by 2. But the cool thing is we do it twice because it's twice per year. So in the end, this formula becomes that, and we just need to ask ourselves, when does this become 8036? Okay. And so we went from the word problem to the math, so now it's much easier. So we basically get 7,000 times 1 plus 0.028 to the 2t equals 8036. So 7,000 times 1.028 to the 2t equals 8036. And then let's divide this. So therefore, 1.028 to the 2t becomes 8036 divided by 7,000. This does simplify, but I don't want to, it's simpler as an exact number, but it looks like a decimal, so let's just keep it that way. And now what do you do to this equation? Well, to get this t out, just apply logarithms to this. So let's do ln of this equals ln of that. So ln of 1.028 to the 2t equals ln of 8036 divided by 7,000. And then the 2t comes out. And so you get 2t ln of this thing, 1.028, equals ln of this 8036 divided by 7,000. And then last but not least, to find t, you just divide this whole shebang by 2 ln of 1.028. So you then get the following. T equals ln of 8036 over 7,000 divided by 2 ln of 1.028. And now we can calculate this. So in the end, this becomes roughly 2.50 years. So not bad. All right, 2 more questions left. Okay, now it's a very long word problem, but here I summarize it. So suppose you're injecting a certain drug into a patient, and suppose the amount of drug after h hours is 45 e to the minus 0.25 h. So it's decaying exponentially, and the question is, when is the drug dosage? 17 milligrams. So all we need to do is solve 45 e to the minus 0.25 h equals 17. Okay. And then we want to solve for h, so e of minus 0.25 h equals 17 over 45. And last but not least, because we want to solve for h, let's just apply ln to both sides. So ln of e of minus 0.25 h equals ln of 17 over 45. But ln of e is just whatever this number is. So minus 0.25 h equals ln of 17 over 45. This is so much fun. It's like being back in chemistry class. So h just becomes minus ln of 17 over 45 divided by 0.25. So like multiplying by 4. And then we get roughly 3.9 hours. Which might be the length of this video, I don't know. And the last question of the day, or I guess the last question of the night, the end of our marathon. Suppose you have a bacteria population that's modeled by y, the population at time t. It's y naught e to the 0.059t, where y naught is the initial population. The question is, when does the population double? What does it mean for the population to double? If initially you had y naught bacteria, you just need to figure out when the population is 2 times y naught. So if you started with 1 million, you want to figure out when it is 2 million. So essentially we want to know when is y equals 2y naught. But now we have this formula, y naught e to the 0.059t equals 2y naught. And the nice thing is, assuming the bacteria population is positive, we can just cancel out this y naught, and you get e of 0.059t equals 2, which again we can destroy with an ln. So ln of e of 0.059t equals ln of 2. But again, ln of e of something is just that something. So 0.059t equals ln of 2, which tells you that t equals ln of 2 over 0.059. So let's calculate that. Which becomes roughly, again, round your answer to the nearest tenth, 11.7, again, in this case, hours. And this, ladies and gentlemen, finishes our marathon extravaganza, extreme algebra, whatever. And I hope you like this. If you want to see more math, please make sure to subscribe to my channel. Thank you very much.